Hello friends, and welcome to Escaping the Mouse with your host, me, Breck Rowell. Alright, I gotta admit, I didn't really know what I was going to do this weekend, but I saw something pop up on my Facebook page that I've seen actually pop up a whole bunch of times that I've been kind of meaning to think I wanted to take a look at. Up in Dallas, there is a museum, kind of natural history and that kind of stuff, called the Perot Museum. And like I said, it's been bombarded on my Facebook timeline a whole bunch of times, and I decided today we're going to go up and take a look at it. I think this is going to be pretty cool. Let's go. Yeah, kind of interesting architecture. Oh, and look, there's dinosaur tracks to follow. I get the feeling this place is kind of geared towards children, but I like a lot of these museums that have like some things that kind of encourage a little interaction here, and there seems to be a little of that here. So my appointment is at 1 o'clock and it's about 12:30, so I'm a little early, but we're going to get in and try and see if we can escape the heat a little bit. Maybe we can wander around the cafe or the gift shop, see what they got. So this is our first friend here. This is a Mawalisaurus or a Mawalisaurus, kind of named for the area it was found. Obviously this is the whole thing. This is just a skeleton, and I don't know how well you're even seeing it with the backlit, but I think this is kind of an indication that we're going to see some fun stuff in here. And they got all these things up here that are supposed to be water molecules, and I don't know, they got cameras up here, so when somebody walks under them, they all kind of move. Almost looks like hidden Mickeys, doesn't it? This is a big, massive place with lots of levels. I guess they have a traveling exhibit of a T-Rex exhibit here, and I have an appointment to go in and see that. So I think we're going to hit that first. And I think that's probably right here. Okay, along the wall, when you come into the T-Rex exhibit, they got life-size to scale drawings of each of the different types of dinosaurs. So you can kind of compare them to each other. And there's our friend, the T-Rex. And this is a map here that kind of shows the habitat of the T-Rex. Looks like it's pretty much just in a straight line right here in the northern hemisphere. Quite a few of them here in North America. Oh, and the different color codes. I guess the yellow is during the Jurassic. The kind of light blue was the early Cretaceous, and the dark blue was the late Cretaceous. So it seems like the T-Rex was more prominent in the late Cretaceous. This is some of the early ancestors of what later became the T-Rex. You see, as time went by, they got bigger and bigger. Yeah, there he is right there. Now, a lot of times with these dinosaur fossils you see in the museums, they aren't the actual fossils or the actual bones. They made a casting of the real bones so that they can reproduce them and put these in different places in different museums. And that's the case here. This isn't an actual rest. This isn't the actual fossil of a T-Rex. It's just a casting of one. But it is actual size.
Every skeleton has a story.
Yeah, look at those little arms. It's no wonder it was so mad. Could never reach anything. More early ancestors of the T-Rex. Now it's interesting, they're showing a lot of these now with like fur versus scales, which is what you would have often thought about when you thought of a T-Rex. But the truth is, we don't know. You know, we get the bones, and all we can do is imagine what they look like. You know, with skin and muscles and whatever covering or fur they may have had. This little display kind of simulates how the animals move. I don't know how well you can see that in there, but what they look like walking. Now this display here kind of shows different sizes of the T-Rex at different ages. That one's probably just about the size of a turkey. Almost looks like a duck, doesn't it, with that head? That's 1 year old, and then 4 years old. This thing, you know, slouching the way it is as tall as I am. And then we got the adult over here at 20 years old. Now in the movie Jurassic Park, they kind of portrayed the T-Rex as having really poor vision, and it couldn't see you unless you moved. But according to this, it had actually really sharp vision, hearing, and a sense of smell. And they basically can do that, figure that out by looking at the amount of space in the skull where the brain would be. And they can say, okay, well, that's the optic nerve, had really good vision, eye movement, olfactory, that's a sense of smell, hearing. So, yeah, maybe it wasn't quite as blind as we think it is. I don't know, it looks like it'd make a good pet. Check out this amethyst. Actually, one of the things that kind of caught my attention on the Facebook page is apparently there's an amethyst in here that's even bigger than this one. And this one's pretty big amethyst. I don't know, what do you think? Would that look nice in my front yard? Could probably do it. Wouldn't have to anchor it down. It's not like somebody's going to steal that, right? So as I said when I was coming in, this place has kind of interesting architecture-wise. And apparently there's like 10 different exhibits in here. So we're going to try and walk around and see as much of this as possible. Fortunately, like I said, they let me in a little bit early, so, you know, maybe I don't have to rush through. Look at what's waiting for us at the top of the elevator here. Going after a little snack. Fast food of the Cretaceous. So this little section here is about the universe and how that all works, and some of the discoveries here. Evidence for the Big Bang. Space age, the first satellite, Sputnik. We got the Hubble here, the Chandra, James Webb, Voyagers 1 and 2, New Horizons, Arecibo, which unfortunately was destroyed a couple years ago when it was neglected to the point where the whole thing collapsed. That was a tragedy. The Keck Observatory that's on the Big Island of Hawaii. Never been up there. I've been on the Big Island, but never been up to see that. You can see it from lower down though. Okay, yeah, this guy's talking about how they can tell that the universe is expanding. Basically what they can do is they can tell what a star is made out of by looking at the distribution of colors. And there are certain frequencies in the rainbow that get absorbed when by certain chemicals in the star. They call those absorption lines. And when a star is moving away from you or moving towards you a very high rate of speed, the color shifts a little bit, and by measuring how far away or how much that color is shifted to either the red or the blue, we can figure out whether a star is flying away from us or flying towards us and how fast it's going. This little part here is talking about the speed of light and how we measure distance in light years. A light year is the distance it takes a beam of light to travel a year. It goes about 186,000 miles a second, or 300,000 kilometers a second. So it's very, very quick, but
great distances are still, mean that it takes a little while for the light to get here. For instance, our sun is about 93 million miles away, and if the sun were to go out right now, this very second, it would be 8 minutes and 20 seconds before we found out on it, and when it started getting dark on Earth. And then you consider that the stars you look at in the sky, the light from those stars left that star years, decades, centuries, or even millions of years ago, depending on how long or how far away it is. That's always kind of blown my mind. It kind of really demonstrates how big the universe really is. Yeah, see, I was talking to you about absorption lines a little bit ago. Those are the absorption lines. They've broken the spectrum up, the rainbow up into a big long strip, and you can see all these little dark spots along the way where the element in the star has just absorbed that color of light. And by studying that, we can tell what the star is made out of. And if we find that all these lines move one way or another on the spectrum, that indicates that the star is moving towards us or away from us. And that's how they can tell that the universe is expanding. This little exhibit here has a little light source and a prism here, and you can rotate the prism around. You can turn on the light source, and you can see the rainbow form here. Look at that. Now this is something that's kind of eluded scientists for a long time. They figure out, based on the gravitational constant of the universe, that we don't see most of what's out there. All the stars, all the planets, all the moons, all the rocks, all the asteroids, all the comets. They think that makes like 4% of total what's there. And this is kind of everything else broken up here. 0.4% stars, 3.6% intergalactic gas, and then 23% dark matter and 73% dark energy. Those are things that are out there that we can't even detect them. We only know that they're there because we can see their effect on the rest of the universe. Okay, this display here talks about the different type of stars and their life cycles. Some of the smaller ones start off as a protostar, turn into a brown dwarf, and then just kind of fade out. You get a little larger, you get a red dwarf, continues to be a red dwarf for a while, and then collapses on itself into a white dwarf. This is what our sun is like. It's a yellow star. Eventually, when it burns off all of its hydrogen, it will begin to expand and turn red. And when that happens, it'll absorb Mercury, Venus, Earth, and probably Mars and parts of Jupiter too. And eventually, when all that energy is burned up, it'll turn into a planetary nebula, and then there'll just be a white dwarf at the end. A little larger, you get a blue supergiant or red giant, and it can go back to a blue giant or just go straight to a supernova and then turn into a neutron star. Even larger yet, you go from the protostar to blue supergiant to type 2 supernova to a black hole, and they get bigger and bigger from there. Biggest one turns into a supernova. Okay, this exhibit here talks a little bit about the moon, and remember a few months ago we had a solar eclipse in Texas, and we saw it went right through the path of totality. It was amazing. And this is what happened here. This is the sun, and the moon passed between the earth and the sun, and the moon's shadow got cast on the earth, and we went right through the path of totality. And this, of course, talks about the moon's effects on our tides. If you have the moon and the earth, or the moon and the sun on opposite sides, you get extra high tides. And the same as if they're on the same side, then you get big high tides also. But depending on the position relative between the sun and the moon onto the earth, that can affect our tides and the size of them. And this little area seems to deal with all of our solar system, so it's the sun and the 8 planets. And so this is a kind of a scale that shows how big the different planets are relative to each other. There's the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Yeah, so you can see how big they are. And then each one of these displays here deals with each of the individual items. So we got the Sun here, Mercury, talking about its size. Venus is almost our twin. It's slightly smaller than the Earth, but it's an entirely different kind of world. That's even though Mercury is closer to the Sun than the Venus is. Venus has a really thick cloud cover, and so it is far and away the hottest planet in the solar system. In fact, early on in like the 70s and 80s, they sent a probe to Venus, and the probe melted before too long because it was so hot. And then of course we all know Earth and our moon and Mars. We're starting to learn all sorts of things about Mars these days because we got rovers that have been exploring the planet, helicopters, we got things in orbit watching it constantly. Then we start talking about asteroids. See, between the orbits of Mars and Jupiter, there's an asteroid belt. And so some of these asteroids, are pretty good size. In fact, this is another example of what later became a dwarf planet. This was an asteroid in the asteroid belt that was so big that originally it was identified as a planet, but they later revised the definition of a planet, and this, and most famously, Pluto, got demoted. Jupiter, when you get to the outer end of the solar system, you start getting into gas giants. These things are really huge. These things are actually closer to being stars than they are planets, because they don't really have a solid surface. It's just a gas cloud held together by gravity. And if Jupiter was like 10 times larger, the heat and pressure generated inside would make it glow like a star. A couple of its moons: Saturn's moon Titan, Uranus and Neptune, and of course then we get the poor old demoted Pluto. In fact, a lot of people don't know this, but they've discovered a new planet in the outer parts of the solar system that they're calling Eris. And Eris is actually larger than Pluto is, but it's still being called a dwarf planet because they redefined what constitutes a planet versus a dwarf planet. A lot of things in the universe get big enough that they compress into a sphere, like this asteroid, or like Pluto, or like Eris. But it has to have cleaned out the part of the galaxy or the part of the solar system in its orbit, so there's no more debris in there. And that's what happened with Pluto. See, Pluto is in a section of the solar system called the Kuiper Belt. And the Kuiper Belt has lots of comets and asteroids still floating around in there. And Pluto will never be called a full-on planet until it cleans out its orbit. And that may happen in a few billion years, or it may never happen. Now this section here seems to be dealing with the fossil record. And so you see a lot of little fossils here. And this isn't actually a fossil here. This looks like these are fossilized footprints. And those too, right? Looks like little feet there. So a fossil isn't always just the animal itself. It could be evidence that the animal left behind. And that right there is called coprolite. And basically it's dinosaur poo that's been fossilized. So there you go. Trying to rise the standards of this video, so we gotta talk about more dinosaur poo. Some plants that left fossils. conifers. So those are ancient seeds. They almost look like some of the seeds that you can see today on modern trees, huh? And there's a leaf. Sea life, mollusks. Look at that bug. And trilobites. I have a couple of trilobites in my collection. Probably not as nice as that one though. That looks like kind of an ancient crab of some kind. Look at them that way. You can see the pinchers in the front. Some fossilized fish. Little starfish. There's a couple of fossilized dinosaur eggs. And a big head. That looks like a big giant iguana back there. Probably something like that. Kind of looks like an iguana, doesn't it? If you ever wanted to run into a 4-foot tall iguana. Then we're getting into dinosaurs there. Check it out. Check out that. That looks like someone that 65 million years ago would have been a good friend for Flash. Yeah, that's a tortoise. Look at that. I don't know if you can see that, how well you can see that, but it's like, looks like the head of some sort of a lizard. Look at that guy. Look at the tail on that thing. That's 6 feet head to tail on that. Doesn't look like something that big, but that would definitely ruin your day. Look at those teeth. One of the cool things about this place is it's very tactile. There's a lot of things that you can touch and explore. Now, the things they don't want you to touch and explore are generally a long ways away or behind glass or something, but this is definitely designed for kids that love to touch and explore things. The skull of a little ground-dwelling lizard from 280 million years ago. And look at these skulls. A lot of the early mammals. If memory serves, these were some of the first animals that kind of were straddling the line between reptile and mammal. So these are our great grandparents, maybe. That looks like something out of a horror movie, doesn't it? Sounds like something you should be battling with silver bullets after a full moon. Yes, they call this one a teethosaurus. That looks like something that probably swims. That's the skeleton of a monitor lizard. That's about the size that they get now. Sometimes monitor lizards get even bigger than that. But then we got something here on top that's altogether different. Look at how thin and long that one was. And the tiny pointed little snout. I don't know if you can see that. Okay, this thing is probably about 30-35 feet long. Lived in the oceans 80 million years ago or so. It's called a Tylosaurus. They say this specifically lived in the oceans of Dallas. Remember, I've told you a few times that at one point, kind of central North America was under a shallow sea. So it might have only been, 50 or 100 feet deep, but a lot of creatures lived in here. And then they got this big dude hanging over the top of us here. They got one of these in the Mayborn Museum. I've seen those too. But that's like an 80 million year old tortoise. Yeah, just for the record, that head is way bigger than Flash. Flash would probably fit in that thing's eye hole. So yeah, that thing's, you know, probably 10 feet head to tail. Looks like it'd have kind of a bad attitude too, doesn't it? So this exhibit here kind of deals with the fact that dinosaurs are very, very similar to each other, but we're on opposite sides of the world. And it makes the argument that there was a land bridge between North America and Asia, that these dinosaurs were crossing millions of years ago, hundreds of millions of years ago. In fact, some of the early Native Americans that came to the U.S. Followed that same land bridge. And now we're sort of getting into the Pleistocene era. That was like, you know, 50,000 years ago up until, you know, 5,000 or 6,000 years ago. And these are woolly mammoths. You remember I took you to the Woolly Mammoth Museum in Waco a few years ago where they found the skeletons, a whole bunch of these. But yeah, look at the size of that thing. That is a fully assembled woolly mammoth skeleton. At least 3 times the size of any elephant I've ever seen. Look at those tusks. Ruin your day. So apparently there was an Alamosaurus, and this is it. Wonder if he remembers the Alamo. And then he's right next to a T-Rex. So T-Rex is big, but this guy's even bigger. Check this out. Dinosaur footprint, probably castings of dinosaur footprints, because a minute ago they had like lights underneath them so you could kind of see stuff going on. I don't think they would have cut holes in an actual dinosaur footprint, but still it kind of gives you an idea how big these things are. Now I remember when I went to the La Brea tar pits in Los Angeles that they actually had a window like this where you could actually watch actual scientists restoring bones. Yeah, here we have a paleontologist here cleaning up a bone, getting some of the debris off. Kind of interesting to see this. Some kind of interesting skeletons here. That apparently is one of these things. They seem to be more all the hood ornament and all the stuff on the top seems to be for, you know, battling each other and probably defending property and probably defending against a mate and stuff like that, you know. And in case you were wondering, this section seems to deal with birds. All kinds of birds. See, one of the theories is that certain species of dinosaurs, especially the ones that walked on their hind legs, like the T-Rex and all that, actually evolved into birds. Because you compare, you know, the skeletons to the structural structure, or the skeletal structure of birds. There's a lot of similarities. It's a pelican. Look at that skull. This is something here to discuss. One of the differences in the skeleton of birds. Bird skeletons tend to have large holes and air pockets, so they maintain the strength and yet have a very, what they call a honeycomb-like structure that gives it the strength but without the weight. And so like this exhibit here shows the difference between like a mammal bone, which is pretty solid, and a bird bone, which is porous and filled with holes. Alright, this is just a little exhibit for the kids that let them pretend to be a bird, so the way they move their wings or their arms. Looks like they can try and fly through an obstacle course here. That's kind of cool. And this is that paleo lab I showed you a minute ago. I didn't even look up, realize they got dinosaurs on top of it. And look at the pterodactyls, pterosaurs, flying up there. not flying that well. I mean, I guess he probably doesn't have quite enough wingspan at this point to fly, but can you imagine those things flying around the sky, eating whatever they want? And look at the backbone of this thing here. Yeah, pretty big.
All right, now as sometimes happens when I do one of these videos where I take you someplace and show you something, I end up with way more content than I originally planned. So I'm going to end the first half of this video today. We'll pick up the second half next time. You're not going to want to miss that one. That one's going to show you the museum on rocks and minerals, and you're not going to want to miss that one. So thank you as always for watching, and I'll see you next time on Escaping the Mouse. Good night.